Hi, welcome to the channel. In today's video, we'll be doing some data analysis with Pandas and Scikit-learn. The idea is to work with the Bandcamp's dataset. This company, they basically have an e-commerce site where you can buy music, albums. It's kind of similar like Spotify, but you can actually just buy what you want instead of buying a subscription. I think it's a very real world type of dataset. It's not like watered down. So I think it's good practice to work with it. The idea is to do some simple exploratory data analysis with pandas, and I'll be using scikit-learn in order to do a little bit more complex analysis using the text of the songs. Yeah, let's get started. I'll start with the EDA part, and at the end of the video, I have this example using scikit-learn. It's a little bit more unconventional. I think it's interesting. You can take a look later. So what is Bandcamp? So Bandcamp is kind of like Spotify, but basically they sell each item individually. So it's not a subscription business. They literally just sell songs. They sell t-shirts, I think. And I think it's an interesting business. And the other perhaps unconventional thing they do is that they let you pay more than the list price for an item. So some people just post the songs for $0, so just for free, and some people just buy them and just give it away in a way, pay just extra. So that's kind of interesting. So this is the data set we have. So we have some sort of ID identifier that it's the sale URL and the timestamp. So basically, it's this item was sold at this timestamp. So that's what make it unique. And then we have the URL, the item, the artist name, the album title, some image, the item type. So this is digital albums, physical items, digital tracks, slug type, albums, merch, and tracks. So these two basically determine what kind of item is being sold. There's the date, but the date is it's an epoch. The epoch means like the number of seconds since one particular date in 1970s. There's a way to convert that to Pandas daytime. And then there's the country code, the country, and here we have the price information. So this is the item price, how much it was listed in the seller's currency. And then there's the currency. So there are multiple countries, so there are multiple currencies. So one thing to keep in mind. And this is the amount paid in the seller's currency, and this is converted in dollars. Okay, so let's get to it. So here I'm importing some libraries. So just going to run that. Here I'm reading the file, so pd read CSV, just pass in the file name, and I chose engine PyArrow. That generally reads it faster, but it doesn't always work, so you have to be careful. I generally try it first. If it works, great. So in this case, it worked. Okay, so this is a head of the data. More or less what we saw above. We have this kind of empty column here, so we can see it in the columns list. So I'm just going to delete it. And now I'm just doing a head of two observations and transposing it. I just find that sometimes this is easier to look at the data. We have this ID kind of variable, art URL, the item type, the timestamp, so it's a number, and country code, country. This we don't have anything here. Slug type, amount paid. So this is the amount paid with the currency sign, basically. This is without the sign, but some pre-processing was made here. Item description, article ID. I guess this should be integer, but doesn't matter. URL. So this is kind of like the album, I guess. So amount paid. So this is in the currency, right? It's the same as this, but without the sign. So it was pre-processed. So basically, the item price is the list price, and the amount paid is how much the user paid. And then we have the amount paid in dollars. So it was already converted. So you can see that the pound was converted to $1.3. Who knows when that conversion was done? Okay, so this is the code to convert the epoch to a daytime. So let's see if this works. Let's try this. Okay, so basically this is what's happening. So we have this float representation of a date, and we convert it to a timestamp. So just run that. So here are some examples what's happening. How many days of data we have? So we have, if I do the min of the date, the max just subtracted, I get 22 days. So we have kind of like a month of data. And okay, I'll start doing some high level statistics about the earnings of the artist. So here I'm grouping by the artist name, just keeping the amount paid in dollars column and taking the sum. So let's see how this looks like. So okay, here we can see that there are 159,000 artists. Each has their total amount paid. You could divide this by 22 to get a daily number if you wanted. But yeah, I'll just leave it like that. Okay, so how does the distribution look like? So this is a very typical tool I use in Pandas, the quantile function. So basically, it splits the data in 10 groups. So here I'm passing the groups that I wanted to be split, and it just tells me the value at the start of each group, right? So, and okay, here I can see the minimum value is 0.00220, the top value 97. This gives me an idea of the distribution a little bit more clearly than a histogram. So here we get the 0.510 seems to be the median dollar spent per artist during this period, right? Okay, so here we can see that most of the artists, they get paid, between 0 and 82. Then if we zoom in here, we can see that they get paid a lot more money. So let's take a look at that. How does it look to the distribution inside between these two decimals? So if I start in 0.90 and I go to 1 with a smaller step, so that's what I'm doing here. I'm passing these breaks. So what I see is that, okay, they in the 90th percentile, they start earning $82, but this starts growing, and I mean, it's a decent amount of money. I mean, but yeah, these are the top earners, right? So, but yeah, we can see that this group of people, they make a lot more money than the rest of the distribution over here. And we could plot these also. So these are the from 0 to the 90th percentile. So this is how the distribution looks like. So here I'm filtering the data and just showing 0 to 82 value, and just selecting 30 beans that generally works well. Okay, we can see that this distribution is very positively skewed. So, I mean, and that will generally tell us that the mean will be a lot higher than the median. And generally in these cases, I prefer to use the median instead of the mean because it's kind of more realistic. If I plot the histogram of the high earners, I can just do the same thing. Just start the data in 82 and let's say plot up to 2000. And we get a similar situation, right? That we have a very positive skewed distribution. So that means that some of the people make a lot of money, and most of the musicians or people that are selling stuff in the websites, not just music, they make less money. So, okay, so here we have the data again. So one of the other columns we have that could be interesting to look at is the country. So let's do some computations with that. Let's see what we find. Here I have computed the value counts of the country, and I'm just showing the top results. I'm plotting them as a a bar chart. So basically, this is what you get. So the way I interpret this is the number of sales per country during this period. And I can just plot it as a bar chart. And that's made very easy by Pandas in this case. I think for this kind of simple plots where we are exploring the data, using this is great. I don't want to, write, a lot of code to make a bar chart. Yeah, we can see that the top countries, they are the ones that, are have the most transactions. The US, UK, Germany, and then it starts dying down. Mostly developed countries. Here I have another summary statistics by country. So let me unpack this part. So I have the data frame here. I'm grouping by country, and then I'm doing an aggregation. So in this aggregation, what I'm doing is counting the number of items sold. So here I'm passing the variable, and here I'm passing the function I want it to be applied, and I define the column name. So what this syntax allows me to do is that I can use a column here and a different column here. So then I'm doing the median of the amount paid, the average of the amount paid. So that's what's happening up to here. And then I'm piping this function sort values. So then I'm sorting the results by number sold. So this variable that I created here. And I'm just showing the top 20. A little bit more complex type of aggregation. But we can see the same thing here, the number sold. That's what I computed before. And here we have the median spend for this time period, 22 days, and the average spend. So we can see here what I was mentioning before, that the mean is generally larger than the median when you have a skewed distribution. But yeah, I mean, in some cases, they are not that different. So, I mean, 6 and 8, I mean, not that far. But you have these values, right? The median is 2, and here the mean is 5.2. Okay, so the next aggregation I did is related to item type. So here we have what the variables mean, but I think it's easier to just look at the results. So the item type has these values: digital album, physical items, digital tracks. So I'm just creating a dict with like the value, the coded value, and the description. It's just easier to work with the description. Let me show you what this looks like. So this is the after I do the mapping, this is how it looks, right? And what I've done here, I'm just starting with the data frame, grouping by these two columns, and then I'm doing these aggregations that they look very similar to what I did before. The only change is the total spend. And this gives us an idea of kind of like the business, what's being sold more. So we can see that the physical items, for example, here, they have a higher median spend and a higher mean spend. So they also sold quite a bit in total. So if you compare this value with this one, it's kind of about the same. So they make similar amount of money with digital albums and with physical albums. And then okay, then what else? So yeah, digital tracks. Okay, look at the difference between these two values. So the median is 1.5 and the mean is 2.21. So still it's a lot higher. So I mean, if this would be 3, it would be 2 times higher. So but it seems they make the most money with digital albums rather than just selling tracks. So I don't know, it's a good way to summarize the business. Okay, let's continue. So then there's also the relationship between the amount paid and the item price, the list price. So here I'm showing some examples. So we can see that in some cases they're different. For example, this was listed at $1 but it was paid $3. So what I'm doing here, I'm computing the ratio. It was overpaid, so basically the amount paid divided by the item price. So MPWare, what it allows me to do is kind of like a vectorized if-else condition. So what I mean with vectorized is that it applies it on the entire vector, so you don't have to do a loop. It's very fast because it works powered by NumPy. So basically what I'm doing here is if the item price is 0, we don't want to do this division, right? So I'm just setting that as 0. And if it's not 0, then evaluate this condition. Here I'm doing the decimals. So these are 10 groups. And okay, we see like we have this situation with zeros. So that means that the item price was 0. And there we have on the higher end, some crazy values. So someone paid like $1,249 more than the list price. So very generous people in this website. Here's a kind of simple calculation that I created. So okay, let's filter the data and just keep the rows where the overpaid ratio was larger than 1. So someone paid more than the list price. So what is the median of those values? So that's what we get here, 1, 2, 5. So what happens if I do the mean here? So we get 1.86. So that means 86% more than the value, and I think 12.5% more is a lot more reasonable. So that's kind of like the advantage of the median. It's a little bit more robust. What I'm doing here is computing the total of the amount paid, dividing it by the total of the price, and then subtracting 1. So, and this gives me the global percent that, the overpayment in aggregated terms. So we can say that 15%, 15.66 is the number, the percentage of the items that were overpaid. And I can convert that to dollars. So almost $1.4 million of data was overpaid. I think that's interesting. The total sales for this period were 8.9 million in dollars. 15% of that was this kind of overpayment. Okay, so another thing you could look in this data, is there a pattern in relation to the seasonality? In order to do that, the first thing to do is just plot the time series. So here I'm doing a value count by date. So just counting the observations by date, and we get this plot. I mean, this shows that there's some sort of seasonality here, so probably weekly. So that led me to the idea that there might be something different going on by weekday. So what I'm doing here is computing the day of the week, just adding the weekday name. So there's a function for both of these in Pandas. And here I'm grouping by both of those variables and just computing the median sales and the overpaid ratio. So basically, the advantage here again is that we can pass in 2 different variables and actually 2 different functions. So let's say, I mean, maybe the median makes more sense. Okay, maybe the median is not very interesting. So what do we get here? The median sales, they look like about the same except for Friday. And the overpaid ratio is a little bit higher, not a lot higher. It just happens that on Fridays there are a lot of albums releases, so it just people spend more on Fridays in this website. Finally, we're getting to the text analytics section. So here I'm just running import commands. The next step would be to filter the data. I'm just keeping the data where the slug type equals tracks. So I just want the tracks item. And the idea is to use this item description that has the song title and use them to make some plots and to get some insights from it. So you could do the same with the merge slug type also. Here I have some code in order to plot a word cloud. The idea was to get an idea of the text that's included in the words. So here I'm just running this, and what this shows me is basically a frequency table. So the larger the frequency, for example, remix, original, mix, the larger the word. And I mean, this is kind of interesting. It gives us an idea of what the songs, how they are titled. Like the other question I had is like, what combination of two words in the track name are more predictive of price? So let's say you're a commercially minded musician and you want to make a song that will sell a lot. So, okay, how can we call the song? The way I thought of doing this is first I'm selecting the item price, and then I'm selecting the item descriptions, and then I'm basically converting the text into a representation I can use a model with. So let me explain this. So basically, this is the raw data, right? The text of the song name. So I'm defining this df-idf vectorizer that basically converts the text into a matrix where each column of the matrix is a combination of two words. So, and this is something you can very easily do with scikit-learn. Here I'm quote unquote feeding it to the text, the track name. So now it's able to convert text into a matrix format. Now I use this df-idf object that I created, I call transform, and I pass in the list. That basically creates this xall matrix. And the advantage of doing this in scikit-learn is that this is a sparse matrix. So it doesn't take a lot of memory. I mean, these are 319,000 elements. It's not, so these are the ones of the matrix. So the advantage of this sparse matrix is that it doesn't store the zeros. Okay, and then what I can do, and I think this makes it a lot clearer, is I define this linear regression object, and then I fit it to the data. So I use the xall, so this is matrix that we created, as the features, and the track price as the target. I'm going to run this. So these are the coefficients of the model sorted from larger to lower. So basically, what am I showing you here? So each of these variables, there are combinations of two words, and they are ordered by how much they correlate to a large amount of the large price the item was published. So you would think that the words that appear here, or the combinations of words, they are relatively correlated to getting sold at a more expensive price. And then you can also look at the kind of worse ones. And I mean, to me, I don't know, if I see this, what I can get out of this is that there are a few DJ mix ball, remix, something related more like to electronic music. So it seems electronic music is getting sold well in this website. But if you look at the kind of worst titles, I mean, there's also Friday mix here, so it's kind of unclear. But let's say, okay, Shaz, I don't know, it's some of these combinations of words, they might be very low frequent, very infrequent, or more related to moshioks. I don't know what that is. I don't vampire dance, maybe not a great name for a song. I mean, and you could do this for one word also. So I mean, I chose just two words, but we can just leave it at one. So let's say I change here the df-idf vectorizer, and I just leave it at one. So I'm just run everything again, and we can see here the better words. I mean, it it doesn't look very useful here. I don't know. I mean, it just, yeah, maybe it's not a, maybe we need more features. And let's see if I put two. This might take a little bit longer, but just curious what happens. But should work. So, okay, we get a different kind of result. So, so now we have, as I changed the vectorizer to work from 1 to 2, we are able to create features with one word and with two words. So that's why you see these two-word combinations. And okay, I mean, session life, interesting. Remix again, and these I don't know why they are here, but okay, I think maybe this is a valid approach to be a little bit more commercial minded musician. I mean, I just wanted to do something a little bit different than just pandas in this video. I hope you enjoyed it. Please subscribe and like the video. Thank you very much.